at the end of 2 years you can exercise the option because it is a European call option, and they are given the parameters or the variables. Up factor, U is the up factor, so 1.15. This means every period, or because it's a 2 year, we have two periods, that is T0 initial, T1, T2. Okay, so if you write it like T0, okay, at T0, then there are this is at T1, okay, then it is at T2, and this can be exercised only at the end of 2 years. The up factor is 1.15, that is 15% gain, 15% gain in the stock price. Here, of course, the stock is the European German blue chip equity index. So it is the German blue chip index. That is the underlying instrument, and the down factor is 0.9. That means a 10% decline. And we have what is called pi, which is the probability factor. Because in a binomial model, you have there are only two outcomes. So one is probability, that is happening, not happening. This is given as 0.5. So this pi is needed to calculate the value of the option. And then the index price, that is here, index price is euro 720. So this is the time of initiation of this option, and the strike price, so say x is the strike price, is 750. And they given hedge ratio, which is 0.5697, and 1 year rate, risk-free rate, is 3%, and S is equal to 648, and C is equal to 0. This is the underlying portfolio, which is the blue chip index value, and this is the value. C is the value of the call option. Okay, now this is the first exhibit. So based on this exhibit, there is one question. Using the binomial valuation method and the data in exhibit 1, the price measure paid 1 year ago for the call option with a strike price of 750 is closest to. So what is called the 1 year ago, the price is, so we have to find C0. Okay, 0 in that it is time 0. This is a C1, C2. Of course, it is up. This is a plus 15%. This is minus 10%. So I will say C1 plus C2 minus. This will be C2 because at the end of time plus C2 plus minus. This will be C2 minus plus C2 minus minus. Hope you understand this notation. This is C means value of the call option. This is at 0, time 1, time 2. Because there is a 2 year, there are two time periods, 0 to 1 and 1 to 2. And 15% up, 10% down. At for each period, the change can be. So if it is plus, I'll put plus, and this is minus. Okay. So we define all these values. They're asking to find C0. What was the price he paid according to the binomial valuation method? Okay. Now how to do this? So I will just work it out here like okay. Now here let us do like this. So we need at every point we need, there are two things or actually three things: underlying, call, hedge ratio. Hedge, I'll show hedge ratio. This is at T0. Now the price goes up by 15% after one period, which is 1 year. Here it goes down. Again we need to, what is the underlying? That is the blue chip index value. And this is the call and this is the hedge ratio. So again this will be underlying, call, hedge ratio. This is a T1. Next T2. Again there are two possibilities or outcomes, because it is a binomial model. You have only two possibilities. It is not a continuous distribution. So here at time it is UL, call, hedge. UL, call, hedge. So each one 15% up. This is 10% down. Or you can say UD. You can write it as U because you know the values. And just put it in like this. This is the lattice. This is the two-step binomial lattice. It is called binomial lattice. Now, initially the price is given as 720, the initial. Okay, now this is C0, and now use the notations for time period. So this is C0. This I can say UL0, or I can say S0. This H0. Okay, this will be, because it is up factor, it is based on up factor, this will be S1 plus. This will be C1 plus. So you should change the notation like this. I mean, or you can write like when you do this, but just to explain, I have showed it like okay. Now this will be C1 minus. This will be S1 minus. Likewise, this will be, underlying will be S2 because it is a 2 period, plus plus 2 ups, 15 15 each period up. This will be H2. This will be C2 minus minus, S2 minus minus, S2 plus minus, minus plus. Okay, this is H2, H2, H2. Okay, this is C plus plus. This will be C plus minus or C minus plus, whatever. C minus plus, it can be two types. Okay, now let us see. First, put the, what you are doing is, first you have to put the S value, which is the spot price, or basically the underlying value. So 15% gain, 720 becomes 828. 10% drop, 720 becomes 648. So multiply by 0.9, this multiplied by 1.15, and this becomes 952.2, 952.2, and the down one will be 828.9 times 0.9, this will be 745.2. This will be 745.2, and this will be 583.2, and that 10% fall. Now, because it is a call option, what is the exercise price? Exercise price is given as 750, and because it is an European option, it can be exercised only at the end of 2 years after the end of the period. So when this option will have a value, positive value, when the when not negative value, when because the value of any option is greater than or equal to 0. Even a put option, the value will be greater than or equal to 0. These are conditional contingent claims, right? There is a right but no obligation. Okay, contingent claims. Okay, now, so in a call option, when the underlying goes above the exercise value, so the value of this one we know after 2 years will be simply S minus X, that is 952.2 minus 750. So this value will be 200.2, 202.2. This value we know from that. Very simple, 202.0. There will not be hedge ratio because this is the last period. This is the last period. There will not be hedge ratio. Only you have the underlying and the option value, call option value. Now, when this is at 745, it will, because it is less than the exercise price, this value will be 0. Similarly, because if 580 is less than the exercise price, this value will be 0. So these are the values. Now we need to find C1 plus and C1 minus. Okay. Now for calculating that, the formula is calculating the value of a call is equal to present value pi C plus 1 minus pi C minus. This is the value for this is the formula for calculating the value of the option. So when I say I want to calculate this value, that is after one period, when there is an up move in the underlying. So C1 plus is equal to PV. PV is the discount rate is given as the 3% risk rate. So the PV becomes 1 by 1 plus 3%. Becomes 1 by 1 plus 3%. And the value of pi is given as 0.52. So we are finding here. So this will be we need C plus and C minus. So because it is C1, so the next period, that is C2 plus plus, actually it is C2 plus plus and C2 plus minus. So C2 plus minus. Now this value C2 plus plus is 202.2 plus 1 minus pi will be 0.48, and the minus one, that is C2 minus, it is 0. This is 0. So this value comes out to 102.08. Now this value, next way to find out, it will be 0 because both this is 0 and this is 0. So both outcome, the call option value is 0 because the underlying is below the exercise price. So this value will be 0. So using the binomial model, this is the way we need to calculate this one. Now once you know these two, I will come to hedge ratio. Once you know these two, you can calculate the value of C0, which is what is required. So C0, now I will change it here. C0, PV 1 by 1 plus 3%, the risk weight is the same across each periods, 0.52 times, this will become 102.08. So I am calculating here, the next nodes are 102.08 plus, this is of course 0, so this comes out to 51.54. This is in euros, so it is a euro, because this is underlying index is a euro based index. That is the price Messer paid 1 year ago for a call option with a strike of 750. This is the how using the binomial model. This is the price which he would have paid. Now what about the hedge factors? H1, H2. Okay. So the hedge ratio can be obtained by the formula for a call option C plus minus C minus divided by S plus minus S minus. The difference in the up and down call values divided by the difference in up and down underlying values. So for example, if I want to calculate this H1, so I have to take the up and down. So the up value is 202.2 minus 0 divided by the up price is 952. The up price is 952.2 minus 745.2. So this will come to around 202.2 over 207 is 0.9768. 9768. Of course, we have the hedge ratio, and this part we can calculate the value of the call option. Okay, so that is also there. Like there is this formula: call option equals PV, the present value of HS, or you can say this is if you want to replicate HS plus C. Let's see, this is the, I will just give off. This is the no arbitrage okay, HS plus PV of HS plus C is the basically the financing term. The financing term, whether you borrow or lend. So if it is a call option, you borrow. Then if it is a put option, you lend. And there is this the value of a call option is equal to hedge ratio times the underlying plus the present value H. minus S minus plus C minus. So the call option can replicate a portfolio with the hedge ratio times underlying plus this is borrowing. This is the borrowing minus HS plus C minus. This is borrowing. Okay. So this is how the value of a call option can be calculated. Now they have given one more thing in this. So replicating the call option by purchasing the amount of underlying shares designated by the hedge ratio, and then this is one. The call option can replicate. Okay, this is the purchasing. This is by purchasing this one. And this is basically from the no arbitrage condition. Arbitrage condition. What is the net cash flow? Purchasing the underlying share designated by the hedge ratio plus the borrowing. The borrowing is given as the present value, which is 1 divided by 1 plus R times the hedge. HS plus C. Okay. Now, so here in this case, if you work it out, the C0 will come as 51.54, and this one hedge ratio will come as 0.5671. This again, this one you have to take C plus minus C minus. C plus is 102.08, C minus is 0 divided by 828 minus 648. This comes to 0.567. So if you want to replicate the portfolio, so 1 divided by 1.03 times how much you need to borrow. 0.567 is the hedge ratio times S minus is 648. So that is equal to 356.79. So when you are plus C, the 648 is when it falls by 10%, and the C value is 0, and the C value is 0. So based on that, you calculate the 356.79 euros. Okay, so this is the second one he's asked. And does the put option with a strike price of euro 750 currently offer an arbitrage opportunity? Okay, this is when they're given a thing that the index has fallen down by 10% to this price, 648 euros. So 645. The strike is 750, and the index has fallen down 10%. So this is this value is 648. So what is if you exercise the put option? This is, of course, they are given an American style option. So in the case study, it is given as this is an American style index option. So you can exercise at period 1, even though it's for 2 years, you can exercise. So when you exercise the put here, What is the value of the put? Put will be x minus s, that is 750 minus 648, that will be 102. She's calling from long time. I don't know what happened. Okay, so that is 102. Now, basically in the question it was mentioned that the market price of the put is 92. So the market price of put is 92. The exercise value is 102. Of course, there is an arbitrage here. So this should be 102. So basically, you can exercise at that 102, and you pay 92. You buy the put option at 92, and when you exercise, you receive 102. Okay, so there is a positive cash flow. There is an arbitrage opportunity in this case. They are given certain assumptions on the BSM model in this case study, and they say that which of the Zillad's assumptions is least consistent with the BSM model. In the BSM model, trading is possible at every instant. That is correct. There are 7 or 8 assumptions. I will read out all those things. Volatility can be predicted with volatility can change, but it can be predicted with certainty. The annualized returns on the underlying follow a log normal distribution. It is not annualized returns. It is the BSM model is based on what is called the geometric Brownian motion, GBM, geometric Brownian motion, which is a random path, a stochastic random path model. And you see here continuously compounded returns. The continuously compounded returns follow a normal distribution. It is not the annualized returns which follow the normal distribution, is one of the assumptions of the BSM model. I will read out all the conditions. The first is GBM, normally distributed continuously compounding, and based on the geometric Brownian motion. The underlying instrument is liquid, continuous trading is available, short selling is allowed, no friction like taxes or transaction costs, no arbitrage opportunities available in the market. Options are European style. The BSM is only for European style options. The binomial can be used for American options also, but the BSM model is only for European style options. Continuously compounding, risk-free rate is known and is constant. Borrowing and lending is allowed at the risk-free rate. Volatility of return is known and constant. Volatility is constant. The underlying plays a yield that is expressed as a continuous known, and its yield is constant. These are the assumptions of the binomial distribution model. Thank you.